Look down for a second. The ground beneath your feet? It actually holds one of the most violent, awe-inspiring, and mysterious histories in the entire universe. Today, we're going to explore a 4.6 billion-year-old mystery. We're going to figure out how our habitable home was actually born. How exactly did an empty, chaotic cloud of cosmic dust and gas somehow transform into the living, breathing planet we know today? Welcome to This Explainer, where we are going to completely unravel the epic story of Earth's creation.
To start, I want you to really picture an apocalyptic wasteland. No blue skies, no oceans, definitely no breathable air. Just an endless sea of fire, constantly bombarded by cosmic debris and totally shrouded in suffocating gases. It seems completely impossible, right? Yet, this literal hellscape miraculously transformed into the beautiful, life-sustaining blue dot we're standing on. So how does a planet go from total destruction to the ultimate cradle of life?
Section 1. The Cosmic Beginning.
Okay, to wrap our heads around the sheer scale of time we're dealing with, we have to go way back. Everything kicks off roughly 13.75 billion years ago with the fiery Big Bang. But our specific story? It truly begins about 4.6 billion years ago, inside this massive, swirling cloud of gas and dust that scientists call the solar nebula. As this dark cloud collapsed under its own gravity, the center became incredibly hot and dense, eventually igniting nuclear fusion to birth our sun. But swirling all around that newborn star was a massive disk of leftover cosmic rubble.
Section 2. Birth of a Planet. Let's move to the actual construction of Earth. And what's wild is that it started with the most humble, tiny building blocks imaginable just floating in that chaotic disk. Tiny dust grains orbiting the young sun began to collide. Thanks to the forces of drag, they stuck together. It's almost like cosmic dust bunnies, clinging together, growing into pebbles, then boulders, and eventually forming massive rocks called planetesimals. These things span tens to hundreds of miles across. Over tens of millions of years, these planetesimals developed immense gravitational pull, crashing into one another, swallowing up their neighbors, and violently building up our proto-Earth.
Section 3. The Giant Impact.
Now, just as the early Earth was taking its shape and settling into its orbit, it faced an unimaginably violent cataclysm that would alter its destiny forever. Enter Theia. This was a massive, rogue protoplanet roughly the size of Mars. Around 4.5 billion years ago, Theia violently slammed into the early Earth. And listen, this wasn't just a bump in the night, it was an apocalyptic impact that completely vaporized rock and metal from both worlds. It essentially melted our entire young planet and flung a massive, superheated ring of glowing debris out into space.
So this swirling disk of vaporized rock and hot gas, what some scientists refer to as a lunar synestia, eventually began to cool. And as it cooled, it clumped together in orbit to create our moon. And here is a totally mind-blowing fact. When the moon first formed from this fiery debris, it orbited a staggering 17 times closer to Earth than it does today. It would have absolutely dominated the sky, looking like a terrifying, glowing giant hovering right above us.
Now you might be wondering, how do we actually know this isn't just a sci-fi story? Well, planetary scientists, like the experts over at the University of Chicago, use modern meteorites and Apollo moon samples to prove it. The Earth and Moon share near-identical oxygen isotopes, which proves they were mixed together in a giant collision. Plus, the Moon is missing volatile elements like potassium and zinc. Why? Because the impact was so intensely hot that those elements literally evaporated into space. We even see the cooling history of the Moon right in its crust. Lighter feldspar floated to the top of a lunar magma ocean to form those bright highlands we see, while younger, dark basalt filled the craters to form the dark patches.
The really crucial point here is how scientists actually date this monumental collision. They basically act as cosmic detectives using radioactive elements. See, before the impact, Earth had already separated into rock and metal layers, but Theia's impact completely remelted and remixed the entire planet. Scientists track the element hafnium, which stays in rock and slowly decays into tungsten over about 10 million years. Because tungsten actually prefers metal, when the Earth remelted, that newly formed tungsten sank straight down into the core. So, by measuring the extremely low levels of tungsten left up in Earth's rocky mantle today, scientists can pinpoint that this giant impact happened roughly 60 to 175 million years after the solar system was born.
Section 4. Oceans of Magma.
So the dust finally settles after the moon-forming impact, but our planet was left as a terrifying, hostile, and just utterly unrecognizable world.
It's honestly hard to reconcile the world we know today with what Earth used to be, a violently hot 6,000-degree molten wasteland. It was covered in a magma ocean literally hundreds of miles deep, shrouded in a super-heavy, toxic atmosphere of carbon dioxide, methane, and ammonia, all while being constantly blasted by intense UV radiation from a young, highly active sun. It's the absolute polar opposite of the tranquil, stable, water-rich world we know today.
But here's the thing. All that intense heat was absolutely necessary. As this molten planet slowly started to cool, gravity did its vital work. Heavy metals like iron and nickel sank deep into the center to form the core, and that core is what gives us our protective magnetic field today. Meanwhile, lighter silicates floated to the surface to create the crust, with the thick mantle sandwiched right in between. This established the very planetary structure we're standing on right now.
Section 5. The Oxygen Revolution. With the outer crust finally solidifying, the stage was set for the most dramatic transformation in our planet's history. So how did we get our oceans? Relentless volcanic eruptions continuously pumped water vapor and gases into the atmosphere. Combine that with a heavy, constant bombardment of icy comets and meteorites crashing into the surface, delivering even more water. As the Earth cooled, all that vapor turned to rain. Imagine a relentless torrential downpour lasting for millions of years, just gradually filling up the vast ocean basins. At the same time, the deep, slow movement of plate tectonics began. This process started recycling carbon dioxide, essentially acting as a global thermostat to stabilize the climate over billions of years.
And then came a monumental shift. The first sparks of life were microscopic, single-celled organisms. And around 2.4 billion years ago, a very specific type of marine life called cyanobacteria started doing something extraordinary. They started using sunlight to produce oxygen through photosynthesis. This incredible turning point is often called the Great Oxidation Event. This was life's most noble revolution. Earth's atmosphere became filled with oxygen. This biological revolution forever transformed our toxic, suffocating atmosphere into a breathable one. Now, while this new oxygen was actually toxic to some early microscopic life, it paved the very foundation for all complex, multicellular organisms, including us, to eventually thrive. Section 6. A habitable world. Over the next billion years, this incredibly dynamic planet didn't just sit still. It continued to constantly and violently reinvent itself. Earth's surface has always been in dramatic motion. From the shifting of massive supercontinents like Volbara and later Pangaea, breaking apart and colliding, to extreme planet-freezing ice ages where the Earth was basically a giant snowball. Mountains were pushed to the sky, massive oceans were formed and destroyed. Earth is just a living, breathing engine of geology.
But of course, this dynamic nature comes at a severe cost. Despite the planet's amazing resilience, life on Earth has faced brutal mass extinctions. Take the Permian extinction period, about 252 million years ago. Massive volcanic eruptions and severe climate shifts wiped out a staggering 90% of all living species. Yet from the ashes of these devastating events, new life always found a way to adapt, evolve, and reclaim the planet.
Now, let's look at an absolutely humbling comparison. Earth has been evolving, shifting, freezing, burning, and creating for 4.6 billion years. Humanity, on the other hand, we've only existed for roughly 300,000 years. To put that into perspective, if the Earth's entire history were scaled down to a single 24-hour day, human beings wouldn't appear until the very last few seconds before midnight. We are an absolute blink of an eye in this epic geological timeline.
Earth is not just a planet. It is an endless poem written by time. Yet, in our incredibly short span, humans have radically reshaped the planet. We've built entire civilizations, harnessed the atom, and reached the stars. But we've also created what some researchers now call the plastic age, leaving an indelible, permanent mark of synthetics and carbon deep in Earth's geologic record. We are the very first species in 4.6 billion years capable of understanding our planet's history, but also the first capable of fundamentally altering its future in just a matter of decades.
Which brings us to a profound realization. We live on an incredibly rare, delicate world that fought through cosmic bombardments, oceans of magma, and deep freezes just to become a sanctuary for life. The survival of this blue dot is now uniquely intertwined with our own choices. So what legacy will we ultimately leave behind in the vastness of the cosmos? Will we just be a brief, destructive flash? Or will we adapt and continue to be a part of Earth's ongoing, beautiful story? Definitely something to think about the next time you look up at the stars, or simply look down at the ground beneath your feet.
Thanks for joining me on this explainer, and keep questioning the universe around you.